Hi, good evening everyone. My name is Karina. I am the Chief Suspension Engineer for this year's team. I'd like to introduce you to all of the members. I am primarily this year responsible for the loading scenarios. I will be assisting Carlos Flores with the kinematics. He will also be designing the steering system. And then we have Greg Mueller, who is our kinetics engineer. Excuse us. And then he will be assisting Sean Parker with the unsprung mass design. Now when you think of suspension, why is it important? Well, this is for a number of reasons. Primarily for the ride quality of the vehicle, and also in the motion of the vehicle while maneuvering. Now, our suspension system sees a lot of loading, and this is because it quite literally suspends the weight of the vehicle. It takes the forces from the tires, moves them into the kinematics, A-arms, and then into the body of the vehicle, which then translates into the kinetics system. And it also absorbs and isolates the brake shock to the driver. And you can design a suspension system in an infinite number of ways. And so it was really important to us this year, not only to take the theoretical optimum suspension system into account, but also to consider what the previous years have worked up to and optimized the car to be already. And the top 4 goals that we came up in order to move the project forward in a more maximum stability and handling way was also to help reduce the weight, to improve reliability of use, and to consider the ease of manufacturing for all of our components. Now we know that our suspension system handles very well, and the competition data from previous years quite frankly proves that to us. We didn't want to completely redesign our system. Instead, we wanted to make as little major changes as we possibly could. And so we decided that we really wanted to only redesign the uprights, and everything else will be more along the lines of adjusting and tuning. And so our purpose for today is mainly just to discuss the options that we considered and show you how we came to determine that the uprights were the most important thing for us this year. I'd like to jump to the kinematics. I will be speaking on behalf of myself and Carlos Flores. When you think of kinematics, we're really talking about the linkages that connect the vehicle from the tires and into the body. And the way that the geometry is configured is what controls the motion. The goals that we wanted to take into consideration this year were really just in optimizing the handling dynamics and also in maximizing the stability. So for the handling dynamics, we want to pay attention to optimizing our camber curves again, making sure that the camber is easy to adjust, and also assist in reducing the CG of the car in whole in order to benefit the roll. Now for stability, we're really just talking about reducing the risk of deflection and buckling and improving the rigidity of it. There are a couple of different types of suspension that we can consider. A dependent solid axle is really not appropriate for application here at CSUN, but we do consider a few versions of the independent. And if you compare the McPherson strut with the trailing arm, as opposed to the SLA short arm that we use, there's too many disadvantages in packaging and also in minimal camber option, which doesn't meet our goal criteria. Instead, we're going to stay with the advantageous SLA short long arm wishbone suspension system to maximize our camber. It gives us compact weight and it's also a lightweight. For the A-arms, same sort of thing to consider. We don't want to change from what we're using. We like to consider just using the non-equal, non-parallel A-arms so we can get a good creative, optimal camber control and a contact patch with the tire. We can play around the roll center that benefits us in handling. We did consider some control arm options, as we normally do for, I think every year we consider different materials and different shapes. So this we tried to compare the round tubing that we use to an oval streamline tubing, mainly just for the resistance to buckling and in the aerodynamics. However, we don't really feel that our car travels fast enough to be able to sort of justify the use of the oval streamline tubing and the aerodynamics, and we still get a pretty reliable use out of the round tubing. As far as the materials are concerned, we did of course want to go with carbon fiber or possibly a titanium option. But the 4130 chromoly really meets our criteria in reliability. Not to mention the fact that the team we really want to finish this competition early. And if we start to go the route of using a carbon fiber, even though it's very advantageous, we are probably going to prolong that, and we're not going to be able to finish early, so we're not going to be able to do a lot of testing. Same with titanium. There are advantages in it being high weight, but there are a lot of manufacturing issues, and also materials has lower availability and is much higher cost. For the geometry, I didn't want to say too much here, get too many specifics, but I want to be clear that we are going to optimize from the 2008 car, especially in the camber. But we will have to make some modifications because of the chassis and the upright. We're going to redesign the upright, and the chassis has new dimensions. There will be some compromise in what it has been from last year. We definitely want to pay attention overall to the roll centers and the roll moments, and hopefully with that early finish date, we'll really get to make use of the camber adjustments. For the suspension mounting joints, this year we like to go with the rod ends inboard and the spherical bearings outboard. The rod ends inboard with the easily adjustable threads that we like, high bearing strength, inexpensive, and it's reliable. And as far as the spherical bearings are concerned, those also have a high radial strength. They are inexpensive, and apparently they appeal to the judges in competition, so we'll use those. We considered some material changes for the rod ends, so we wanted to try and contribute to the overall reduction of weight for the team. And a nylon composite is something we looked at because it's 80% lighter. However, upon further analysis, we did sort of realize that the loading that we see is probably too enormous for us to go with something like this, because the static radial load capacity is much lower than that which we use with the steel alloy. We want to keep away from that. We're going to stick with the steel. There are quite a few things that we can say here about the wheelbase and track. We did initially consider extending the wheelbase, and those were for some spatial considerations. However, after we sort of looked at the trends that have been going on since previous years, like from 2006 up to date, we see that we are decreasing the wheelbase. We see that we are sort of keeping our track at a good equal front to back and at a wide range. Did some research, trying to figure out how we compare to some top teams, etc. And really the feedback that we got was that we are at an optimum range with top competing teams. So this is very important to us. It'll create a lot of extra change with the other departments to play with the track and to extend the wheelbase, and so we don't want to do that. Again, we want our early finish date, we want to stay with something that we know is reliable and that performs very well.